My name is Sanyasram, Mathematics faculty. Now I am discussing quadratic equation in fourth chapter. Quadratic. Okay. Now 4.1 introduction. In chapter 2, you have studied different types of polynomials. You know that. What is the polynomial? General equation of the polynomial. What is the general equation of the ax square? Sorry. Ax square plus bx plus c. This is the quadratic polynomial. Polynomial we have denoted p of x. This is equal to a naught plus a1x plus a2x square plus so on an x to the power of n. This is the general equation of the polynomial. Different types of polynomial: linear polynomial, quadratic polynomial, cubic polynomial. Linear polynomial, any polynomial we have to decide it, the variable highest power. The highest power of variable. The highest power of variable is 1. That is the linear polynomial. The highest power of variable is 2. That is quadratic polynomial. The highest power of variable is 3. That is cubic polynomial. The nth degree polynomial means the highest power of variable n. The highest power of variable is n. Variable తో highest power n అయితే దాన్ని nth degree polynomial అని చెప్పి చెప్తాం. Okay? That is the different types of polynomial. One type was the quadratic polynomial. You know that one type is quadratic polynomial ax square plus bx plus c. Ax square plus bx plus c. Ax square plus bx plus c. Clearly a is not equal to 0. Because of here variable is x. Here variable is x. The highest power is 2. Variable is x. The highest power is 2. So that is quadratic polynomial. That is quadratic polynomial. X square coefficient ఏ వాల్యూ కానీ 0 అయ్యేటట్టయితే ఇక్కడ x తాలూకు హైయెస్ట్ పవర్ 1 అయ్యింది ఈ పోలినామియల్ లీనియర్ పోలినామియల్ అవుతుంది. సో ఖచ్చితంగా the coefficient of x square is must be not equal to 0, then it is called as a quadratic polynomial. When we equate this polynomial to 0, we get quadratic equation. Generally ax square plus bx plus c, that is the polynomial of expression. Quadratic polynomial of the expression that is equal to 0, that is the quadratic equation. That is the quadratic equation. Okay. What is that? Polynomial denoted p of x. This is equal to the general form of the polynomial a naught plus a1x plus a2x square plus so on an x to the power of n. For suppose highest power of the variable, the degree of the polynomial, degree of polynomial is n. So this is nth degree polynomial. Nth degree polynomial. This is nth degree polynomial. This is nth degree polynomial. For suppose degree of the polynomial is equal to 1. That is the linear polynomial. N is equal degree of the polynomial. N is equal to 2. That is the quadratic polynomial. Degree of the 3. That is the cubic polynomial. This is equal to the simplest example ax plus b. This is equal to ax square plus bx plus c. This is equal to ax cubed plus bx square plus cx plus k. This is here a not equal to 0. Here also a not equal to 0. Here also a not equal to 0. That is the linear, quadratic and cubic. For suppose any polynomial is equal to 0. And this is the expressions. Ax plus b is the linear polynomial expression. Ax square plus bx plus c. This is the quadratic polynomial expression. Ax cube plus bx square plus cx plus d. That is the cubic polynomial expression. A naught plus a1 x plus a2 x square plus so on. An x to the power of n. That is the nth degree polynomial expression. For suppose this is equal to 0, ax square plus bx plus c. This is equal to 0. That is quadratic equation. That is the quadratic equation. Any expression that is equal to 0, any expression that is equal to 0, that is called as equation. That is called as equation. That is linear equation, that is quadratic equation, that is cubic polynomial equation, that is nth degree polynomial equation. Any polynomial, any expression that is equal to 0, any polynomial, any expression equal to 0, that is called as equation. That is called as equation. Okay. When we equate this polynomial to 0, we get, that is the quadratic equation. Quadratic equations come up when we deal with many real life situations. For instance, suppose a charity trust decided to build a prayer hall having a carpet area of 300 square meters with its length 1 meter more than twice its breadth. What should be the length and breadth of all? Suppose the breadth of all is x meters, then the length should be the 2x plus 1 meters. We can depict this information pictorially as shown in figure in 4.1. This is okay. Now area of the rectangle, length into breadth. Length is equal to 2x plus 1. Breadth is equal to x. 2x plus 1 into x is equal to 2x square plus x. Okay. But totally 300 meters square. 300 meters. 2x square plus x is equal to 300. Therefore, 2x square plus x minus 300 is equal to 0. It is clearly quadratic equation. So, the breadth of the hall should be satisfied the equation 2x square plus x minus 300. Now we can solve the x value. The length and breadth we have to find. Okay. Many people believe that baby Babylonians were the first to solve quadratic equations. For instance, they knew how to find two positive numbers with a given positive sum and given positive product. And this problem is equivalent to solving quadratic equation of the form x square minus bx plus q is equal to 0. That is, Greek mathematician Euclid developed a geometrical approach for finding out lengths which in our present day terminology are solutions of quadratic equation. Okay. Solving quadratic equation in general form is often credited to ancient Indian mathematician. In fact, Brahmagupta, the century is 598 to 665, give an explicit formula to solve quadratic equation of the form ax square plus bx is equal to c. Ax square plus bx is equal to Sridharacharya, century 1025, derived a formula now known as the quadratic formula as quoted by Bhaskara for solving a quadratic equation by the method of completing the square. By the method of completing the square. Who is that? Sridharacharya. An Arab mathematician, A1 Khwarizmi, about century 800, also studied quadratic equation of different types. Abraham Bar, Nasi, in his book Liber Embadorum, published in Europe in century 1145, gave complete solution of the different quadratic equations. In this chapter, you will study quadratic equations and various ways of finding their roots. Quadratic equations, we have to finding their roots. You will also see some applications of quadratic equations in daily life situations. Quadratic equation in the variable x is an equation of the form ax squared plus bx plus c is equal to 0. where A, B, C are real numbers, A is not equal to 0. For example, 2x square plus x minus 300 is equal to 0 is a quadratic equation. Similarly, 2x square minus 3x plus 1 is equal to 0. This is also quadratic equation. Similarly, 4x minus 3x square plus 2 is equal to 0. This is also quadratic equation. And similarly, 1 minus x square plus 300 is equal to 0. Because of here the variable is I, the variable is x, the variable is x, the highest power is 2. The variable is x, the highest power is 2. So that is the quadratic equation. The highest power is 2. So this is quadratic equation. The highest power is 2. This is the quadratic equation. The highest power of 2. This is the quadratic equation. The variable highest power is 2. This is also quadratic. So also all are quadratic equations. In fact, any equation of the form P of x is equal to 0, where P of x is a polynomial of degrees 2. P of x is a polynomial of degrees 2. This is the any equation is of the form P of x is equal to 0 is a polynomial of degree is 2, that is called quadratic equation. But when we write the terms P of x in descending order, their degrees, then we get standard form of the equation. Standard form of the equation is ax squared plus bx plus c is equal to 0, where a not equal to 0. That is the called standard form of quadratic equation. What is the standard form of quadratic equation? STANDER. Standard form of quadratic equation. Question is ax squared plus bx plus c is equal to 0, where a not equal to 0. This is the standard form of the quadratic equation. This is P of x is equal to ax squared plus bx plus c, where P of x is equal to 0. This is the ax squared plus bx plus c is equal to 0 and a not equal to 0. A not equal to 0. This is the quadratic standard form of the quadratic equation. Okay. The quadratic equations arise in several situations in the world around us and in different fields of mathematics. Let us consider a few examples. First one, the following situations mathematically. John and Javanti together have 45 marbles. Both of them lost 5 marbles each, and the product of them, the number of marbles they now we have is 124. We would like to find out how many marbles they had to start with. First, John and Jayavati together have 45 marbles. For suppose John had X. John had X. For example, John X అయితే total marbles ఎన్ని ఇద్దరు కలిపి 45 కాబట్టి Javanti is equal to 45 minus x. 45 minus x. Both of them lost 5 marbles. Both of them lost 5 marbles. ఇద్దరు కలిపి 5 marbles లాస్ అయ్యారు. అంటే when he lost 5 marbles. He lost 5 marbles. Both of them lost 5 marbles each one. అంటే ఇక్కడ ఏమవుతుంది ఇద్దరు కలిపి 5 మార్బుల్స్ ద నెంబర్ ఆఫ్ మార్బుల్స్ left with John when he lost 5 marbles x minus 5. Javanti and the 45 minus x. 45 minus x. Therefore, both of them, the number of marbles left with Javanti when she lost 5 marbles. 45 minus x minus 5. 45 minus x minus 5. Therefore, 40 minus x. 40 minus x. Their project. 5 marbles loss and their project number of marbles is 124. And 45 x minus 5 x 45 minus x. అంటే లాస్ అయిన తర్వాత x minus 5, 40 minus x. X minus 5, 40 minus x. That is 40x minus x square minus 200 plus 5x. Therefore, minus x square plus 45x minus 200. Therefore, that is total product is 124. Therefore, x square minus 45x plus 324. That is the equation. That is the required representation of the problem is mathematically the number of marbles John had satisfy the quadratic equation x square minus 45x plus 324. Again, I can explain. John and Jivanti together have 45 marbles. మనకి ఎవరెవరు ఉన్నారు? Example 1. Example 1. First one. John and Jivanti. John and Jivanti. And this is the x and this is the y. Therefore, x plus y is equal to how much? 45. X is equal to 45 minus 5 and y is equal to 45 minus x. Here, this is the clearly polynomial. Polynomial means having only one variable. Having only one variable. Here, y is also we have to converting x variable. Y is also have to converting x variable. So, John is equal to x marbles. Jivanti is equal to 45 minus x variable. Jivanti is equal to y. Therefore, y is equal to 45 minus x. Okay. Next. Both are, what is that here? Is lost 5 marbles. Each one is 5 marbles. John lost 5 marbles. This implies x minus 5. Jivanti lost 5 marbles. This is equal to 45 minus x minus 5. This is equal to 40 minus x. Okay. This is the equation number 1. This is the equation number 2. But here see that and the product of the number of marbles. What is the product of the number of marbles? The John left of marbles and Jivanti left of marbles. That is the product. What is that here? It implies x minus 5 into 40 minus x is equal to how much? 124. That is the clear. That is the clear. Now, we would like to find the how many marbles they had the start with us. X minus 5, 40 minus x. X minus 5, 40 minus x. X minus 5, 40 minus x is equal to 124. This is equal to 40x minus 200. 40 is multiple చేసాం 40x minus 200. మళ్ళీ 5 చేద్దాం 40x minus 200 minus x square plus 5x is equal to 124. 40 అంటే this is minus x square plus 45x minus 200 minus 124 is equal to 0. Therefore, minus x square plus 45x minus 324 is equal to 0. Minus the multiple x square minus 45x plus 324 is equal to 0. This is the satisfied required equation. This is the satisfied required equation. Required equation. This is the satisfied required equation. A cottage industry produces a certain number of toys in a day. A cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys proceed in a day. The cottage industry produces a certain number of toys in a day. One day lo a certain number of toys ను produce చేస్తుంది. The cost of production of each toy was found to be 55 minus the number of toys. 55 minus the number of toys produced in day. On particular day, the total cost of production was 750 rupees. We would like to find out the number of toys produced on the day. The number of toys produced on the day X అనుకుంటాం. మనకి ఏం తెలుసు the cost of productions ఎలా ఉంది each of the day 55 minus X. 55 minus X. అంటే మనకి నెంబర్ ఆఫ్ టాయ్స్ ఏమనుకున్నాను నేను ఎక్స్ అనుకున్నాను. వాడు ఏమన్నది అంటే ఇక్కడ చూడండి. వాడు ఏమన్నాడు ద కాస్ట్ ఆఫ్ ప్రొడక్షన్ ఆఫ్ ఈచ్ టాయ్. ప్రొడక్షన్ ఆఫ్ ఈచ్ టాయ్ that is the production of each toy was found to be 55 minus the number of toys. 55 minus the number of toys next అనుకుంటే దాంట్లో ఏం చేయాలి ద ప్రొడక్షన్ ఎంత అని చెప్పేసి అనాలి 55 minus of toy. 55 minus of 55 minus of okay 55 minus of toys. The total cost of the production is 750 rupees. Total cost means the produce of the toys and per day collection 55 minus X. Total is X into 55 minus X. The total cost of production. అంటే ఎన్నైతే మనం ప్రొడ్యూస్ చేసామో అన్ని కూడా దాని కాస్ట్ కావాలి per day. The cost of production in rupees each toy. ఒక్కొక్క టాయ్ తాలూకా కాస్ట్ 55 minus X. ఒక టాయ్ తాలూకా కాస్ట్ 55 minus X అంటే మొత్తం X టాయ్స్ తాలూకా కాస్ట్ X into 55 minus X. That is equal to 750. 55X minus X square is equal to 750. That is equal to X square minus 55X. That is the required representation of the problem math. చాలా ఈజీ క్వశ్చన్. కాకపోతే ఏంటంటే మనకి కొద్దిగా క్వశ్చన్ అండర్స్టాండ్ చేసుకోగలిగితే చాలు. ఓకే మళ్ళీ ఓకేను ఒకసారి. ఓకే ఇక్కడ చూడండి ఒకసారి. The cottage industry produces a certain number of toys. Number of toys ని మనం అనుకున్నానంటే X అనుకున్నాం. Toys is equal to X. కానీ మళ్ళీ ఏమంటున్నాడు వాడు నెంబర్ ఆఫ్ టాయ్స్ X అయితే the cost of production of each toy was found to be 55 minus the number of toys. 55 minus the number of toys. 55 minus number of toys. The cost of each toy is equal to ఎంత అవుతుంది 55 లోంచి నెంబర్ ఆఫ్ టాయ్స్ ఎలిమినేట్ చేస్తే ద కాస్ట్ ఆఫ్ టాయ్స్ ఉంటుంది. అంతే కదా. ఇప్పుడు టోటల్ ప్రొడక్షన్ మనకి ఏం కావాలి ఇప్పుడు అయింది కదా. ద ప్రొడ్యూస్డ్ ఇన్ దట్ డే on particular the total cost of production was 750 rupees. Total cost of production ఎంత అమ్మా total cost of production is total cost of production 750. But here number of toys in X. Each toy cost is 55X and total cost of xn x into 55 minus, okay, x into 55 minus. Both are equal. Therefore, x into 55 minus x is equal to 750 rupees. This is equal to 55x minus x square is equal to 750. This implies x square minus 5x. This is minus 750. This implies x square minus 5x plus 750 is equal to 0. This is the required equation. This is the required equation. Check whether the following quadratic equation, are quadratic equation, x minus 2 whole square plus 1 is equal to x minus 3. X minus 2 whole square plus 1 is equal to 2x minus 3. Quadratic equation అవునా కాదా అని చెక్ చేసుకోవాలి. This is x square plus 4, 4x plus 1 is equal to 2x minus x square minus 4x plus 5 minus 2x minus 3 is equal to 0. This implies x square minus 6x plus 2 is equal to 0. The highest power of the variable, the degree of polynomial, the degree of the polynomial is 2. So, by the above equation is quadratic. Above equation is quadratic. By above equation is quadratic. The above equation is quadratic. Okay. Same as this. Next, second question. X into x plus 1 plus 8 x plus 2 x minus 2. This implies x square plus x plus 8 is equal to x square minus 2x plus 2x minus 4. This implies x square plus x plus 8 minus x square plus 2x minus 2x plus 4 is equal to 0. Plus x square and minus x square plus 2x and minus 2x. This is equal to x plus 12 is equal to 0. X power is the degree of polynomial. Degree of polynomial is 1. So, this is linear polynomial. Linear polynomial equation. This here quadratic equation. The quadratic is not a quadratic equation. Okay. Next one, third one. X into 2x plus 3 is equal to x square plus 1. This implies 2x square plus 3x plus x square plus 1. This implies 2x square plus 3x minus x square minus 1 is equal to 0. This implies x square plus 3x minus 1 is equal to 0. The degree of polynomial. The degree of polynomial is 2. So, quadratic equation. Quadratic equation. So this is quadratic equation. So this is quadratic equation. Fourth one. X plus 2 whole cube is equal to x cube minus 4. This one plus. A cube plus B cube plus 3 A square B plus 3 AB square is equal to x cube minus 4. This implies x cube plus 8 plus 6x square plus 12x minus x cube plus 4 is equal to plus x cube minus x cube cancel. This implies 6x square plus 12x plus 12 is equal to 0. This implies x square plus 2x plus 2 is equal to 0. The degree of polynomial is 2. So by the above equation is quadratic equation. Is quadratic equation. Is quadratic equation. Okay. First equation is quadratic equation by giving equation is quadratic equation. Second equation is not a quadratic equation. Third equation is a quadratic equation. Fourth equation is a quadratic. Okay. Be careful. Above given equations appear as be quadratic equation, but it is not a about to given equation a be a quadratic equation, but it is not a quadratic. And for above the given equation appears cubic equation, an equation of degree 3, not a quadratic equation, but it turns out the quadratic equation, as you can see, often we need to simply the given equation before deciding whether it is a quadratic or not.